Hello and welcome to another episode of the Classical Republican. This is part 2 of our interview with Bailey Flanigan and Paul Golz. And we're talking about the algorithm. All right. So here we are back at the graphic. And so we kind of left off right here. And this blue square stands for one pool of people. That was part of the selection process. And then would you want to talk about this up here? And so these right here, they represent the well, do they actually? So these represent like one demographic, or are they representing like everybody and the probability? Or can you go into a little more explanation on what that is?
Sure.
Yeah.
So go ahead, Paul. Okay. So each of those, in this very stylized figure, represents one person. Each little person represents one person in the pool of volunteers who have said, yes, I would participate if I was invited to participate, but we haven't chosen the actual panel yet. And so what this is showing is the little gray bars above the people are a representation of their probability of being chosen for the panel itself. And you can see this little link thing, the little chain. This is linked to the distribution that we described before over panels, like those groups of people who we might choose. And the reason those are linked, as we described before, is that the chance of me getting chosen is really just the chance that a panel is chosen with me on it. And so that's what that part of the figure is representing.
Okay. All right, thank you. And so you can only be on one panel, or can you be, because of your probability, you can be on multiple panels? Is that correct?
Yeah.
Many, yes.
Got it. So for example, how would that look? So say you're a part of a minority, and this is definitely a targeted minority that you want to have on the panel, on the final panel, because of the nature of the topic. Is that correct?
Yes.
Okay.
Then to me, the next question is not just, are you in a minority or not, but are you in a minority that participates, that is very likely to sign up for the pool, or that is less likely to sign up for the pool? So for example, you could be part of a minority that is very enthusiastic to participate in the pool. And then even though you make up a small share of the population, and your group should only make up a small share of the panel, in the pool, there will be many of you because all of you signed up. Everybody was excited. Everybody maybe had a lot at stake. And that will probably mean that you individually have a relatively small chance of being selected. The algorithm will try to push you to still have a very decent chance of being selected. But that is one side of the coin if your group is turning out at very high rates. They could also be that your minority actually turns out up at very low rates. And I hope I said the opposite just now. If your group is very rarely participating, then you will have the opposite situation. Your group is relatively small in the population. It should be relatively small but sizable on the panel. But in the pool, there's very, very few people like you. And that means that to get a representative panel, any algorithm will have to choose you with very high probability. So now you're very happy personally. You can essentially, you don't even have to watch the dice being rolled. You can pretty much count on being on there. But the algorithm will try to take away as much probability as it can from you and give that to those who are unlikely to be chosen. So minority or not minority, in some sense, doesn't even have such a large effect on what this selection looks like for you. It's much more about whether your group and people with similar features as you, because you belong to many groups at once, where they're very likely to participate or very unlikely.
Okay, very good. Okay, so when we get to this part in step 2, is that the final outcome? Everyone is selected and they're coming to meet at the assembly, or is there?
So step 2 is basically where we spin the wheel. Step 1 is we're building the wheel. We're defining the size, to steal Paul's very nice analogy, shamelessly. Basically, the second step is just the random spin of the wheel, and then we choose the group of people, and that little blue square is the group that's chosen, and then they go on, as you said, to deliberate on the issue and discuss a potential outcome.
Okay. And so you're done at that point, and you just go home. They don't need to call you again for anything.
Not me.
So something that does sometimes happen is that people who are being selected on the panel then suddenly can't be reached, or maybe they have a family emergency, and even though they in principle volunteer to be on the panel, they no longer can do that. And this can also happen along the process, so especially for citizens' assemblies that actually last a long time, and some of the largest ones, I think, last for many months, up to a year. So then it can also be that people drop off the panel at some point in between. And then it's definitely not up to us, but the assembly organizers have to choose whether sometimes it's fine to just go on with fewer people. Sometimes they want to replace the people who have dropped out, and then they repeat the same process at a much smaller scale. So rather than selecting 30 or 100 people before, and choosing them to be proportional of the population, they might now only select 4 people and trying to replace the demographics that are now missing from the panel. And so that is sometimes, and relatively often, this is the second stage where they might come back to us. And I believe that this was probably the case also for the Washington Assembly, even though I don't remember it in detail anymore.
Okay, so when you go back and you're trying to replace somebody, so would you focus on their demographic and just up that a whole bunch? Or because so it's not going to be exactly the same. It's not going to be exactly the same on a smaller scale if they are trying to match that demographic. Is that correct? Okay.
Yes, I think that's fair to say. I think typically there the demographics become very important because people from if you have 4 people dropping out, it could be that all of them are women. And then in general, if you would prefer to replace them with women most of the time. Sometimes you can't do that. And sometimes so many people dropped out that you actually can start again having a process of fairness. And the algorithm always tries to push for fairness as much as there's space, but often in the second stage, there's much less space for fairness than the first stage.
Okay, yeah, and most of the citizen assemblies they last about a year, or give or take a year, right? So there's not really a chance of say the body that created it, say it's a legislature, most likely there hasn't been an election, they don't hold it in an election year and then say, the new people want to change things up or anything like that. That usually doesn't that's one of the things they factor into the timing of it. Is that what you've seen?
I believe that typically citizens assemblies are pretty autonomous once they're created. So I don't think politicians have any direct influence, and I think they're actually typically trying to make it clear that they don't have influence. So it's typically in the hands of nonprofit organizations at this point, or other trusted organizations. They are sometimes just respected people. So for example, in the Climate Assembly in France, I know that just respected prominent people from civil life were chosen to be the guardians of the process and to make sure that there was no meddling. So I think typically there's very little political influence in general. And then typically there's no full second stage of selection. So that might be something that maybe actually happens in places like Belgium, which I mentioned, some other places in Belgium, now Paris. These permanent citizens assemblies, there's actually a reselection. So I think, for example, in Belgium, if I remember right, then every person serves for 18 months, and every 6 months, I think a third of the panel ages out of the assembly and is replaced. So that is one of the places where there's an actual rotation, but I think that's still fairly untypical.
Well, that's
sorry. One more thing that I should say is that when we're speaking of citizens assemblies here, and maybe this is why you're associating citizens assemblies with something that lasts for a full year, this is actually equally applicable to things that are called citizens panels or citizens juries or mini publics. So there are many different forms of deliberative mini publics, as you probably know well. And we have chosen one of the catchier names, but for ours, for the selection, it makes very little difference whether this lasts for 1 weekend or for a year.
Okay. And did you say that they use this algorithm in Belgium?
Yes.
Okay. So they have a group like you who's doing the selection every so do they make the selection every 6 months, or do they make it for 18 and then they just have like 3 different groups that participate, or how does that work?
Can you come again with this question?
So like if you from my understanding of the history of the experience in Florence, at one time they had a this is back during the Renaissance. They would have a group of 1,500 people who were a part of this group, the grand like a grand council, and but it was they met in the hall of the 500 because they could only place 500 people there at once, and so they would have for 6 months they would have 500 people in there, and then after the 6 months they would have another third of the 1,500 come meet as the council of 500, and then after 6 months the third group of 1,500. But so how does it are they always are they just on 6-month terms? Is that how it works, or?
No, I'm pretty sure it's like in the US Senate, so they are overlapping
Okay.
waves, which has the advantage that the more senior people can teach the younger people, more junior people how to run the job.
Okay, yeah, very good. Yeah, so they don't lose institutional knowledge and how understand how things work. Okay. Now I know you didn't want to talk too much about specific the citizens' assemblies, but now you got me really interested in what's going on in Belgium. But is there anything more you can tell us about that?
I think I'm probably not entirely the right person for that. So we know that our algorithm has been used there, but we did not run anything ourselves. We know that our code was run by somebody. Everybody can do that. I believe that they collaborated in some capacity with the Sortition Foundation. So yes, I have only read things that are publicly available. I'd be very happy to share one of the write-ups.
Okay, thank you. All right. Did you want to go on to the probability graphic we had here? Where was it? It was it this one, the selection probabilities?
Mm-hmm. Yes.
Mm-hmm.
All right. Let me get that situated. Where can we put us? Let me see. Maybe, I don't know. There we go. That's okay. All right. So what do you want to? So this is the selection probabilities. Percentile pool members, we have legacy, and then the let me get the Leximin. So what's the difference between that?
Yeah, so maybe we can kind of walk you through what's going on in this picture. So Leximin refers to our algorithm. It's the one that we described before, where you're basically trying to push up the lowest selection probability. And then legacy is one of the algorithms that was the most widely used that pre-existed our algorithm. And so we're comparing the performance of the pre-existing algorithm to ours. And in particular, what we're looking for is we're trying to understand what is the probability of selection being given to the lowest half of people in the pool of volunteers. And what we should expect to see potentially, we should certainly see that our algorithm is giving these people some ideally some pretty even though people who get the least probability should have a reasonable amount. And what we're worried about potentially is that the existing algorithm was not doing that we would be seeing that on examples that are actually run in practice, these existing algorithms would be giving some people extremely low selection probability. And this is really what we're doing is we're kind of measuring the impact of our algorithm, comparing what was previously used to our algorithm now. And so that's really what this figure is showing. And there are 6 panels that correspond to 6 different examples from the real world of citizens' assemblies. So we took data on assemblies that had already been run. So that means we took the list of people who are in the pool and all their features and the quotas that were used in that panel. And we said, okay, what would our algorithm do on this example? And what would the existing algorithm do on this example? And so we're comparing them. And across the horizontal axis, let's just look at like the top left corner, this one picture in the top left corner first. Along the axis across the bottom, basically we have percentiles of people in the volunteer pool ordered according to their selection probability. So the people on the left side of the figure represent people who get the lowest selection probability according to the algorithm. And so what you can see happening is the blue line corresponds to the existing algorithm. And what you see is at the lowest end, people are receiving almost no probability of selection. So there are some people who are receiving extremely low selection probability. And then you can see that those people with our algorithm, according to the orange line, see a pretty significant bump in selection probability. And these numbers look really small, but what I want to flag is that like the green line across the top is how much probability people would be chosen with if we could just roll the dice and give everyone the same chance. So that's really like this ideal quantity of probability that we could give everyone, but it's not possible, right, because of the quotas. And so this green line is really like, this is the best case scenario. So even though people are only getting 2%, there's a lot of people in the pool of volunteers and the panel is pretty small. So the chance that anybody gets is going to be relatively low. And I'll let Paul add whatever he wants now because I've been talking for way too long. But yeah, this is basically what we're looking at here.
Go ahead, Paul.
I don't think I have anything immediate to add.
Okay. So if the green line is like rolling the dice, so that's just regular random selection, like no no special demographics involved or anything. Then when we're talking about legacy here, what exactly are we talking about? Like what's being used there? It's not your algorithm. It's not like rolling the dice. What is it?
Yeah. So this is an algorithm that was used by the Sortition Foundation before our work, and it's actually a very neat algorithm. I don't think I can completely explain it, but I think it does something very natural. So it will look at all of the quotas, all of the categories, and will, for each of these categories, say, well, how many more people do we still need from this category? How many more women, say, do we still need? And then it looks at the pool of people and says, well, how many women do we have? And if you divide this one number by the other, so how many you need divided by how many you still have left, that gives you a sort of urgency. If you need many people and there are very few left in your pool, then you better really like now focus on this feature, on this category. Whereas if you only need few of them and you have many of them left, then you can afford to focus on other features for the time being. And so every category now gets an urgency score if you want. And this legacy algorithm will then in every step choose somebody from the category that has the largest urgency. And just there, like inside that group, you just throw the dice and you choose somebody at random. So this is still a random process. It will, in every step, inch towards the groups that are most difficult to represent right now. And so by this virtue, it does a pretty good job at actually coming up with representative panels. And it does so in a random way. But as these plots show, there pretty much always are some people who just fall through the cracks. They never are part of the groups of highest urgency, or only very, very late in the game. So that if they look at this process, really they need to be struck by lightning to be selected. And this is something that our algorithm can avoid because it doesn't just find this one random path through always by the seat of its pants, trying to make all the different features, all the different quotas right. It has this more global view where it can say, well, right now I have a pie chart where you, John, are not being selected very often. Let me try to find some panels that are specifically good for you. Let's add them to the pie chart. Let's make the pie chart overall fairer. So there's a much more global external view, whereas this is more myopic.
Okay. And is the legacy algorithm still in use today?
That's hard to say with certainty, but the legacy algorithm was mainly implemented in a tool that the Sortition Foundation has developed that is open source. that's called Stratify Select. And as of spring 2020, I believe, our algorithm has replaced this algorithm as the default in the same tool.
Oh.
So different organizations that have updated their programs since then and that have not made a conscious choice against our algorithm, which would be perfectly fine. We assume that at this point, our algorithm has mostly replaced the old one.
Congratulations. Very good. Okay. Let's see. So, is there anything else you want to talk about as far as the process goes? I think we're pretty good.
Yeah.
All right. All right. All right. So, okay. Have you ever had any kind of critique or pushback after you've begun your process and they get going and they you know, maybe they think something is your fault or something like that?
Yes, that has happened. And specifically, I think something that is underappreciated a bit right now and that we're working hard to communicate better is that there's often an inherent tension between representativeness and fairness. So, for example, think about a group such as education, where with education, we often see that people with a college degree make up a minority in the population, but are much more excited to participate in citizens' assemblies. So they make up a majority on the pool, and the algorithm needs to push them back down into a minority on the panel, because we want the panel to be representative. And now, there is this tension, and Bailey has mentioned this before. If you're perfectly equal, you will overrepresent the many college degree holders in the pool. And something that we've seen in practice is that some organizations have set these quotas very widely. So they have said, well, we want between 15 and 25 college-educated people. And maybe really they were hoping for 20, or they were hoping for every number between 15 and 25 equally frequently. But because of this tension, the algorithm can get better fairness, can give a more pleasant result to college degree holders by really making use of this leeway and choosing 25 college degree holders rather than 15. And so if these quotas are being set too widely, that in some cases has given rather unexpected results. And so in a sense, the algorithm does exactly what it's being told, but we have to do a better job at explaining how to best make use of the algorithm. We're currently talking to some practitioners in just writing down best practices of how they come up with these quotas, because we can't tell them we're technical people. So that's why right now we don't give them a clear guidance, but we hope that we can find guidance that's actually being given by people who are in the matter and in a place where people find it when they apply the technical tools.
Very interesting.
And
yes, Bailey.
and just to add to this, like another question that I think often comes up, which is a very good question, is, you know, our algorithm is treating basically like the groups that we're trying to protect as the groups that have these features that people running the assembly describe. But one question that people ask is, what about intersectional groups? So we're representing, you know, let's say women like to a proportional level on the panel, and we're representing young people to a proportional level. But are we representing young women to a proportional level, or is it really the case that all of our women are coming from older women and all of our young people are coming from men and non-binary folks? And our algorithm basically like can actually to some degree deal with this, because you can impose quotas on these combinations of features. So you can say, actually, I'm going to define this feature as I am a young woman, and then enforce proportional representation for this intersectional group. The problem, of course, is that you can only do this to a certain extent before it's very difficult to find any panel that satisfies this increasingly complicated system of quotas. And so, as Paul was saying, there's this inherent trade-off between fairness and representation, and that carries over into this as well. So really, I think some interesting future work, and we've done some of this analysis already, but I think doing more of it would be interesting, is trying to understand how to make this kind of trade-off. for intersectional representation and fairness, and making sure that we're hitting some kind of target at the intersectional level as well.
Yeah, and maybe just one thing that I would like to add to this, and is that while one could certainly imagine being more precise on this intersectional representation, we did test this, and we believe that we're not doing any worse than the status quo, than this legacy algorithm. So it's not that you have to sacrifice enormous amounts of intersectional representativeness to use our algorithm. It's more that if you really want to do really well on that, that is still an open space, and right now there are no algorithms that would do that without a lot of manual work telling each group exactly how many people it should have.
Okay. Yeah, I've heard one critique from a member who was a part of the British Columbia Citizens Assembly back in early 2000s, and she said there was an issue with representation of people who lived in rural areas. Have you ever heard any critique like that? And is that factored in to it?
I'm not aware of any. Yeah, I don't think this is something that I've personally ever heard, and I think I don't have any information that, for example, representation of rural versus city would be any trickier than the other kinds of representation. It's not one of the groups where I think we even see a consistent pattern where maybe city dwellers are more likely to participate. I believe that I've seen that come out both ways, and either way, the quotas should make sure that both of these groups are accurately represented.
All right. Well, thank you very much. That's all I have for you. Do you have anything else for the audience before we go? Well, then, thank you very much. It's been an honor having you, and you have a good day.
Thank you for having us. Thank you. You too.
Thank you. Bye.
All right.